So just to reinforce the pattern that we're dealing with, we've got example 1 telling us we have to write exponents as logarithms and logarithms as exponents, and I just realized I forgot the shtook. There we go. Oh, as an added bonus, if you can show me where in the last videos I made a spelling error, then you get an extra point. All right, so a logarithm is written like this. We're used to seeing an exponential equation like this, so we're just going to look at the exponential equation first. Now, a base is raised to a power, and that results in a new number. The base in a logarithmic function goes here. The power is actually what we're looking for, so it becomes the answer. And the number that used to be our answer is here. So what we're saying is, if I'm dealing with this base and I get this answer, how much did I raise it to? So what we're going to do is just rework these patterns as we go here. Pardon me. Pardon me again. My goodness. Okay, I think that's it. So I have a base, an exponent, and an answer. I have a base, an exponent, and an answer. Here's a base, here's an exponent, here's an answer. So let's see. Should we color coordinate this? Why not? I have an exponent that's green. I have an answer that's blue. And I have a base that's red. So I'm going to put it in this format. So I'm going to start with writing log, because it's a logarithm. And then I'm going to write the base down here. So log base 2. And my answer is 32. And I want to get that it equals what exponent? So the exponent is 5, which is what I'm going to write as my answer. Remember that when we're dealing with logarithms, we're trying to find the exponent. So the exponent is the answer. The number that would have been our answer normally is actually right here. This one shows us that we've got this pattern of a negative exponent giving us a fraction. And I want to just start out by recognizing which is which. So I've got my base, I've got my exponent, and I've got my answer. So I'm going to write down my base. I could probably put this in brackets to make it clearer that that's my answer. And they equal the exponent, because that's what a logarithmic function is about. It's about finding the exponent. Here I have another one. Log is what I'm going to write down to start with. And my base is 7. My answer is 1. And that's going to be equal to the exponent, which is my new answer. You get it? Let's try it the other way. Now this one gives us logarithms, and it wants us to put them into exponential. So what I'm going to do here is recognize that my base is 3. So I'm going to write down 3 as my base. My exponent is my answer, so that's 4. That's going to be equal to the answer, which is 81. 3 to the power of 4 is 81. Check, check. Okay, moving on. This one, my base is 5. My exponent, whoops, sorry, I'll write that down. My base is 5, that's what I start with. It's been raised to the power of 3, which is equal to my answer, which is 125. Moving on one more time. I've got a base of 6. It's been raised to a power of 0, which makes it equal to 1. 6 to the power of 0 is in fact 1. So these are some really solid examples of showing you how the pattern works. This is your basic pattern. You want to at least find it on your cheat sheet that I posted for the second half of chapter 5. If not, just write it down and make sure you understand that b to the power of a equals c becomes log base b of c equals a, where a is the exponent because that's what logarithms are for solving.